Hello everyone, and thank you very much for being here today. A very warm welcome to those of you who are in the room at the University of Leicester, and also our online audience who are watching us by YouTube today. My name is Emma Stockley. Can you tell? In our youth series for the Institute for Environmental Futures. My name's Emma Stockley, and I'm a second year PhD student studying archaeology here at Leicester, and I'm also the seminar series convener for the Institute. So the Institute for Environmental Futures, I'll just give you a very, very brief overview. It brings together researchers from all three colleges in a transdisciplinary research programme, the aim being to develop critical understandings of human environment systems in the context of the climate emergency, the global species extinction crisis and environmental pollution. It's led by our director, Professor Heiko Belzer, and Deputy Director, Professor John Gulliver. So I'm just going to mention the format for today. We have two speakers. Heiko is joining us in the room here, and we have Richard all the way from Kenya, who's joining us over Zoom. So we'll have questions afterwards. Those of you who are watching online, if you could please pose your questions in the chat, that's being monitored, and those can be read out at the end of the session. We are making a recording today, so just to let you know, we're recording and it's being live streamed, and the recording will be made available afterwards as well over YouTube. And for those of us that are here, we have refreshments to look forward to at 3 o'clock. One final notice before I introduce our speakers. The next seminar in our series is on the 8th of November, and we're welcoming Professor Ilan Kelman from UCL, so do keep an eye out for those details. They'll be circulated shortly. So on to our speakers. I'm delighted to welcome Professor Heiko Belzer. He's our director of the Institute and is also Professor of Physical Geography at the University of Leicester. He leads the UKRI Strategic Programme Coordination Team on Landscape Decisions and is a member of the National Centre for Earth Observation. And speaking just after Heiko, we have Mr. Richard Mwangi, and he's the Senior GIS and Remote Sensing Officer for the Kenya Forest Service. This is an organisation that manages all public forests in the country, and Kenyan forest ecosystems are some of the most diverse in East Africa, including rainforests, savanna woodlands, dry forests, coastal forests, and mangroves. And Richard has degrees from the University of Nairobi and Kampala International University. So I'm going to hand over now to Heiko. Thank you very much.
Thank you very much, Emma, and thank you very much to everyone who's joining us online and in the room today for this seminar. I'm going to open the seminar by talking about ways of using Earth observation data to try and end global deforestation by 2030. And that is called, for short, the Glasgow Commitment. Last year was at the COP26 in November last year, the climate conference in Glasgow, and world leaders signed the Glasgow Declaration on Climate Change at that meeting, where one of the main outcomes actually was this goal. But let me talk, before I do that, a little bit about the Institute. So we have a number of research challenges that are outlined here on this slide. And you can see what they are on here. And also a cross-cutting challenge on resilience that cuts across the habitable Earth, climate justice, environmental loss and climate risks challenges. We have over 50 leading academic researchers and the research groups in the Institute. And as Emma said, we are primarily focusing on the climate emergency and the extinction crisis in our research. Some of the exciting opportunities we have open at the moment is we have a visiting fellowship scheme where we're looking for people who might want to join us from other organizations. And we have 3 allocated PhD studentships for next academic year to join us in the autumn 2023, where we are currently looking for ideas for proposals. As well as the seminar series that we are organizing. And if you're interested in this, then look up our website. We are engaging with a wide range of stakeholders, including policymakers, activists, NGOs, local communities, schools, and businesses. Our email address is shown on this slide. It's ief@le.ac.uk. If you want more information, just email us. So I was talking about the Glasgow commitment, and the Glasgow commitment essentially was, can I get rid of this bar at the top somehow? Don't think I can. Let's leave it there. So anyway, at COP26 in Glasgow, 145 countries committed to ending global deforestation by 2030. And that covers over 90% of all forest land worldwide. This commitment builds on the Paris Climate Agreement that you will all know about from the media, and the so-called REDD+ initiative by the United Nations to reduce greenhouse gas emissions from deforestation and forest degradation. Together, these policies aim to implement Sustainable Development Goal 15, that is life on land, and that includes the conservation, restoration, and sustainable use of forests, halting deforestation, reducing the degradation of natural habitats, and halting biodiversity loss. There is also an activity on the market. So there are market mechanisms for carbon offsetting and carbon emission reductions. And I just want to mention one of these, that is the Verified Carbon Standard. You can look this up. This is a scheme that a company called Verra operates. And here, countries can basically issue emission reduction certificates that fall into any one of these categories under the REDD+ activities. And these include, for example, avoiding planned deforestation, to reduce greenhouse gas emissions from previously planned deforestation on forest lands that are legally being converted to non-forest land. In the second area, to avoid unplanned frontier deforestation and degradation, to reduce the greenhouse gas emissions from those. These are mature forests on the forest frontier that are being cut. And the third area is avoiding unplanned mosaic deforestation and degradation. So this is in landscapes that are already a mosaic of forest, non-forest land uses. Now, we currently live in a time when we have an emissions gap worldwide. And what emissions gap really means is that the world has committed to try and stay below 1.5 degrees global warming on average to avoid possible dangerous climate change. But current pledges of the signatories of the Paris Climate Conference Agreement only go so far, and the pledges actually put us on a trajectory towards 2.6 degrees global warming. If we look at how many of these pledges are actually being implemented by the governments who have signed the Paris Agreement, then that is an even higher trajectory, and the current policies are only getting us to about plus 2.9 degrees. So that is well above the threshold of dangerous climate change. And this is why I keep using the term climate emergency, because we are heading for a pathway that puts us onto a very dangerous future. So despite all policy declarations, global forest loss is still rampant. Therefore, I believe the world needs rapid forest monitoring solutions, additional data analysis tools, updatable models of ecosystem services, and an understanding of forest cover loss processes and their impacts. So how can we help with this? We have worked on a system we call Forest Alerts, and the Forest Alert system started off in 2014 or thereabouts when we started talking to the REDD+ roundtable, stakeholder roundtable in Kenya for the first time. And we were talking about the need to have rapid access to satellite data of protected forest areas. So it's not about having the best thematic maps a year later, but it's about actually having the next image that becomes available on your phone, on your email, as soon as possible. And therefore, we started to design a system here at the University of Leicester, together with the Kenya Forest Service, to access the Sentinel-2 satellite images from the Copernicus missions. They take images at 10-meter spatial resolution every 5 days worldwide on all land areas. Now, that is the best data set for this purpose that is openly available without incurring a charge, because all these data can be downloaded entirely for free by anyone who has an account on the Copernicus Data Hub. And we implemented a fully automated search, download, and processing function with a machine learning core that delivers near real-time forest loss detections from the latest available satellite image. The Forest Service GIS team basically needs geospatial information for integration into the GIS databases. And for that purpose, we are providing the geospatial information on the forest cover loss areas and their coordinates and some characteristics on the date of detection and other things. And we are also providing information in a simplified form for forest rangers in the field who might need information by mobile phone. So they might not have access to a GIS. They just need simplified information that can be turned into actionable information. What you see here on the screen is an example of one of these forest alerts where you have a forest area here that then essentially is deforested in the next image acquisition. And this was co-developed in our partnership between the University of Leicester and the National Centre for Earth Observation here in Leicester, as well as the Ecometrica-led team in Forest 2020. That was a large project funded by the UK Space Agency, and the Forest Mind team sponsored by the European Space Agency with the satellite applications Catapult as the lead organization. And on the Kenyan side, we were working with the Ministry for Environment, with the REDD+ Roundtable to represent the stakeholders, the REDD+ Technical Working Group, which is more the expert forum on how to implement the REDD+ policies and monitoring services, as well as the Kenya Forest Service as the primary user organization, and the Kenya Forest Research Institute, as well as the University of Nairobi. And in the United Nations, we've been working and are still working with the Food and Agriculture Organization, FAO, in Rome. The system we have developed is called PyEO, Python for Earth Observation, and it's been published this year actually in Computers and Geosciences. This paper by John Roberts et al. Is called PyEO, a Python package for near real-time forest cover change detection from Earth observation using machine learning. And you can access that for free on the journal website. The forest alert system was co-designed and co-delivered. That's an important feature. It is implemented in the PyEO Python library, and it was developed to meet user needs. For several years now, PyEO has been used operationally by the Kenya Forest Service, and Richard's going to talk about that, in protected forest areas in Kwale County and more recently in Kilifi County on the coast. The intention is to scale up the forest alerts to all forest land in Kenya by 2023 in the current project, which is called IMPRESS and is sponsored by BEIS in the UK, by the Ministry for Business in the UK, as part of the UK's official development assistance to Kenya. PyEO links with atmospheric correction software such as Sen2 Core, that's the European Space Agency package, and also the FMASK software library. And it's free and open. On the GitHub page on this slide, you can access the software and see how it's structured, and you can download it and clone it if you like. In the Forest 2020 project, we have actually tested it in Colombia and in Mexico. And what we found here was actually that it produces very high classification accuracies of over 95% user accuracy of the forest cover loss detections and over 85% overall accuracy. That was published in Remote Sensing in this journal paper by Ana Maria Pacheco Pascagasa et al. In the Forest Mind project, which is coming to an end this month, actually, we have translated this into a monitoring system that can be used to monitor farm scale activity for the purpose of supply chain monitoring. And we've been working with importers of coffee beans, of soybean products, and of beef products from South America and Latin America primarily, to try and deliver farm scale intelligence on possible deforestation in the areas around the farms, because importers are keen to avoid any unintended deforestation because of the commodities that they import from these countries. So there is a service being delivered by Forest Mind. You can look this up on the website. Our solution for Forest Mind was demonstrated, for example, in the Mato Grosso state region in Brazil. And we produce a baseline composite of Sentinel-2 data that is shown here in the top left corner and change images from 2021. And then we have automated classifications for both years that are classifying the images in different land cover types, as well as a change map between the base map and the latest available image. As soon as the next image comes in, there'll be another classified map of that image. And then we can aggregate all the change detections for each image that we process. And this is how we aggregate this. And the different colors in the bottom right image here on the screen show how often each pixel has been detected as having changed from forest to something else. So that can be an indicator of confidence in the detection as well. To give you one example, we have here an example of Mato Grosso. Just to zoom in, this is the baseline composite for 2019 that was made from all available Sentinel-2 images in that year, entirely automatically. And it shows an area of forest with a kind of road going across the forest. In the next image here, this seems to be still forested. And as we go over time, there's some atmospheric haze in some images here. The forest is still there. Then part of the forest turns brown. And this could be an indication that there is some clearance beginning underneath the forest canopy. When shortly after that, actually on one side of the forest tract, there's the clearing beginning, and we can see the logging coming in from one part of the image, and then over time, the image is being, the forest is being logged from the left to the right here on the screen until it's all completely gone. The leftovers from the harvesting are put in rows. You can see here these row-like structures in the cleared areas. And as we go further down in time, actually, you can see there's some green stuff also left behind after the harvesting that we can pick up. In our latest implementation of PyEO that we are developing, we have also added another checkpoint, and that is we are looking at the difference in vegetation greenness as quantified through the difference in the normalized difference vegetation index between the baseline composite and the latest available image. And we can use that to filter out some of the noise from the random forest machine learning classification to produce a hybrid change detection image. So that improves the area estimation side of this. It does add a bit to processing time, and it may not be necessary to get a forest alert process. This is more for the area mapping side of the software. There was some organizational capacity building that Richard is going to talk about as well. In Kenya, the Kenya Forest Service runs the software on its own computers every week. So we handed it over to them. We've done some training course, and the Kenya Forest Service are now using this since about 2019, I think. The alerts are used together with geotagged mobile-based phone alerts from local communities as well. So people can report manually if they spot something. And the Forest Information Center in Nairobi starts to screen the alerts and sends coordinates out to forest rangers in the field stations for investigation. And then teams of rangers and community scouts can go out and investigate the alerts. So just to reflect on the main messages from my brief overview of the satellite-based part of the Forest Alert System, it was really crucial to have a co-design process of the Forest Alert System from day one with the Kenya REDD+ Roundtable and the Kenya Forest Service to get the system adopted. Free and open software was a requirement because that gets the software used. I think any commercial software costs are a barrier to its implementation. Two-way capacity building and knowledge exchange were key. And Earth observation information will strengthen forest governance if it is accompanied by the capacity building in the organizations. So we hope to contribute towards ending global deforestation by 2030 by making this software available. And the link on GitHub of the latest version is seen on this slide. So thank you for your attention. I'm going to hand over now to my colleague, Richard Mwangi, for his talk, and then we could take questions at the end for both speakers. Yes, we can see it.
Okay. I'm going to start my presentation. My name is Richard Mwangi from Kenya Forest Service, and I'm a senior GIS and remote sensing officer, and I specialize more on geodatabases, and I'm also a GIS developer. I'm going to do a short presentation of how we have been using the Forest Alert System to do what we call satellite-based intelligence for informed decision-making. This system has helped us to come out to what I would call it from analog to digital, because in the past we had been using papers to record the forest incident, and they were of low quality, and we had a lot of cost in doing patrol, but now with the satellite-based intelligence of this system, we are able to, the forest rangers are able to patrol to a particular place without having to waste fuel doing their patrols. So now the system is able to help us to monitor and be able to detect changes. We are able to, from this system, we are able to do what we call hotspot analysis. And then we are able to do what is called issuance of early warning. For example, during the forest fire season, this has led to better planning and mitigation in the forestry sector. And this has also led to monitoring also of forest fires, because the system is able to monitor when there is forest fire. It's able also to monitor, and because it is using the system of change detection. This system also is being used. We are not only looking at the negative side of it. Our rangers are also able to report on daily basis whenever we have tree planting activities. They are able to report. Also, when there is regeneration in the forest, it's also able to detect, because it uses image of before and after. So in each and every week or in the period of 5 to 7 days, I'm able to run the alerts in our server at KFS, and I'm able to get the changes and send to and share with the rangers on the ground. This is how the system. This is how, in a nutshell, we do the forest alert system is usually done in our systems. First of all, the alerts are usually generated in our servers, and then we have a GIS and remote sensing officer who goes through and picks the actual alerts. That's what we call QN and QC, because this system is currently running on the coastal part of Kenya, and we have persistent cloud covers. So sometimes we may have some false alerts. So we have to do what we call QA, QC. And then the forest alerts are sent to, after we do the QA, QC, we generate the right alerts, and then we share them on our WhatsApp group on a KML file. From the KML file, the rangers have another application called Maps.me. The Maps.me, they are able to open these X and Y coordinates and able to navigate to the area of incident. When they reach the area of incident, they use another mobile GIS tool called Survey123, and they are able to report on the change of that particular area. They're able to take pictures.
Sorry to interrupt. Now we can see it full screen. Okay, thank you.
Okay. This is in a nutshell of how the system, how we generate the alert system from the satellite images. We do QA, QC from KFS headquarters. Then we share the forest alerts on KML format through our WhatsApp group. From there, they are able to navigate to the area of incident using another open source software called Maps.me. From the Maps.me, when they reach to the area of change, they are able to use a mobile GIS tool that is Survey123 to report on the incident. The system has been piloted in Kwale during the forest, was piloted in Kwale during the forest 2020. Are you able to see this slide? Are you able to see the slide, or I'm still on the other slide? Sorry, the system was piloted in Kwale County under the Forest 2020 during the Forest 2020 project. This system, where the rangers were trained and the members of the community. In Kwale County, we have a multi-agency management of forest, where we have KWS and Kenya Forest Service. So we did a training of the members of the community, and also we did the training to the rangers, and also the CFA. CFA stands for Community Forest Associations. The CFA scouts that help in the patrol of the forest. This system has been able to provide information and we have been able to see to do an analysis of the forest incident in a particular county. Currently, it's working in Kwale and Kilifi County. We are able to see the most incident in each and every county and be able to do what we call hotspot analysis in each and every county. We have also been using because due to persistent cloud cover, we have also been using another satellite with the help of Japanese and JICA, which is called the ALOS satellite. We have been running this ALOS satellite for a period of every 5 weeks, and we are able to get changes in the forest and in the mangroves of these particular areas. So this satellite, this system is incorporated with a navigation tools called Maps.me, which uses GPS to navigate, where the rangers and the members of the community can be able to navigate to a particular area using Maps.me. When they navigate, this system is the coordinates to the area of the incident, they are able to reach to that area and be able to send and detect to send the change in that particular area. These are some of the training when we are doing the training and in the field and validation in Kwale County. We have been using Survey 123 as our mobile GIS tool, and it has been we have partnered with ESRI Eastern Africa for the design of the form, and our NCOM department, that is the Forest Rangers department at Kenya Forest Service headquarters. This is an example of the form. This form, when you open it, you can be able to open it using your mobile phone as long as you have Survey 123 and you have the login credentials from the Kenya Forest Service. So you can be able to see there, you have the GPS coordinates, you have the type of the forest where the incident has occurred. Then you have the block name, and then you have the incident. Is it illegal cutting of trees? Is it illegal clearing of forest? Is it illegal possession of logging tools? All those you can be able to see, and then it's able to tell you the date and the time of the incident. So this shows an example of the Kwale County, and it's showing you the GPS coordinate of that particular area, and then these are photos that were detected by the Forest Alert System. These are the photos that were taken by the rangers, and this is from the detection of the Forest Alert System, that the rangers were able to go and check what had happened, and they were able to detect that it was charcoal making in that particular area. This system has been incorporated on a live dashboard. We have designed a live dashboard for these two counties, where we are able to detect, to see what is happening, and the live dashboard is able to refresh in every 30 seconds. And you can be able to see from here, we have a total of 1,902 incidents since 2019 that have been reported. Then you can be able to query in terms of forest types. Is it in the mangroves? Is it in the natural forest? Then the type of incident. From here, although it's not very well visible, can be able to see illegal cutting of trees. So we have, that is the most incident in that particular area. Then you can be able to see what is the source of information. Is it from the forest alerts? Is it from the personal observation? Is it from the ATIPO, from the members of the community? All that you are able to see. Then they can be able to take photos and sign here. So it's a system that is ensuring a lot of accountability and transparency at Kenya Forest Service. So this is Kilifi. This is an example of an area. This is Arabuko Sokoke forest in Kilifi County. So you can be able to see the incident there that was reported by that ranger. It was the illegal charcoal making. This had been detected before by the Forest Alert System. Then we send the X and Y coordinates to the rangers. So the rangers were able to go to that, to navigate to that area using Maps.me. And then they were able to find it was charcoal making in that area. And then they were able to take to report this incident using survey 123. So this is also another area in Kwale County. This is the area. This is the X and Y coordinate. This was just at the border of the forest that is Shimba Hills. This was detected by the forest alerts, the fire, although it had been reported before, but a week after, the forest alert detected change in that area. And when the rangers went there, they saw it's a fire that they had reported on the previous week. This is also in Kilifi County. This is an area in Kilifi County, this area around here. This was detected by the forest alerts. And when the rangers went there, they were able to find some charcoal making in that particular area. So this is where we want to go as Kenya Forest Service. We want to come out from analog to digital reporting, and this will help to ensure sustainable forest management. Due to this innovation and this system, with the help of University of Leicester and other stakeholders, we were able to be awarded as the best organization in the use of GIS technology at the Esri User Conference last year. So we won an award for the best organization in Africa. So this is during the presentation of the award at Kenya Forest Service headquarters, and this is how the system has really helped us. Thank you very much. If I have time, maybe I can show you one of the, because I had opened, if I still have time, because I've been told it's 20 minutes, maybe I could show you some of one of the dashboard, live dashboard. This is, maybe I could go to, this is Kwale. Maybe I could make it a little bit larger. This is Kwale County. This is a live dashboard. So you can see from here, we have the incidents, forest incidents that are reported on daily basis by the.
Still see your last slide. We do not see the dashboard.
Okay. Share. Can you see the dashboard now?
Yes, thank you.
Yeah, this is one of our areas in Kwale County. These are the incidents that have been reported by our forest rangers. So from here, you can see they take photos of the incident. For example, if I go back, I can be able to see one that was reported today. It's able to show you they're able to take photographs of the incident. This was reported today from the alert that I sent, I think 2 weeks ago. Sometimes I don't send alerts on weekly basis because the alert system has been designed in such a way that if there is cloud of more than 75% in that week, on that week, then I'll be not the alert system will not be able to detect any change. So this was sent. I think this was sent. Yes, today. This was sent today because I can see it's 11th of October 2022. This was sent today by one of our rangers, and you can see they are able to sign, and they are able to report the type of incident and the name of the ranger. And then from here, you can be able to see the reporting officer. Is it KFS Ranger, CFA Scouts, or KWS Rangers? Because I've said it's managed by the two organizations, KWS and Kenya Forest Service. This is a live dashboard. So if I want to see the incidents that were from the natural forest, I can click and be able to see. Also, if I want to see the incidents from the mangroves, I can be able to see. So if I want to see the most occurring incidents, for example, illegal cutting of trees, so you can be able to see it. There's a matter of it changes on the live dashboard. So this dashboard has been designed in such a way that it's able to detect change, to be able to come to be received at the headquarters after every 3 seconds. Then you can be able to filter by date. So you can be able to see, I can be able to filter in the last 10 days or in the last 1 week and be able to see what is happening in terms of the incidents reporting. So you can see if I filter in the last 2 days, maybe can be able to see it changes. So if I reset again, you'll be able to see the dashboard is working very well. So these are just examples of the dashboard that we are using at the Kenya Forest Service. This is also another county that is Kilifi. So you can be able to see also, it's able to detect and they are able to take photographs. So if I go to maybe the next one, you're able to see these are some. So if I click on the photo, you're able to see these are some of the photos that are taken by our rangers. Thank you very much. For questions from the audience.
Okay, well, thank you very much to both of our speakers, Heiko and Richard. It's time for questions. Does anyone have a question for either of our speakers? I think Ivan's keeping an eye on our online audience. I don't think we have any online questions yet. So if there's anyone in the room who would like to ask a question, please do so. Yes.
Right.
Sorry, I wasn't sure I could do justice. And
all right. Hi, Richard. I just had a question about how this Forest Sentinel tool, which is obviously very valuable for detection of deforestation, now that this has been running for some time, how is that translating into action and enforcement on the ground? And are there particular types of action that you have been able to target? Is it larger scale illegal deforestation, small scale charcoal production? What does this look like for the communities in these areas?
thank you.
Okay, maybe I can answer the question. The action and enforcement on the ground. From our side, we have what we call a chain of command in the forest, in the forestry sector. On the lowest side, we have the forester who is in charge of a particular forestation. Then we have the ecosystem conservator who is in charge of the county, and then the regional commandant who is in charge of the whole of that region. So when the rangers and the members of the community report this incident, they are able to the action is able to be taken where necessary. A quick action is able to be taken where necessary. I would say what I'm showing here in the pictures or on the dashboard, most of it is not large-scale deforestation. It's just a selective logging, where you find that members of the community might enter the forest and cut one or two trees for maybe charcoal making or for poles. And for example, if you check at my dashboard here, you'll see forest incidences. You'll see the highest number is illegal cutting of trees. That is in Kilifi County. The same in Kwale. So this means that it's just members of the community or poachers who enter the forest and they cut one or two trees. And as long as there is 10 by 10 canopy cover or opening in that forest, it's able to be detected by the alert system. Then the alert system, we are able to send the X and Y coordinates to the forest, to the rangers and the members of the community. Then they go and check what is happening. So it's not a very large deforestation. That's what I could say. It's just selective logging.
Thank you, Richard.
Yeah.
Do we have no online questions? Any more questions from the room? Yes.
I have one more question. I think I will direct my question to Michael. Because you mentioned that you are using machine learning for automatic download. So my question would be, is the system able to detect differences in the incidents? For example, when incidents is happening in protected forest or when it's happening in private farmland, is the system able to make those differentiation? Because I'm just thinking maybe it could be like a burden for people implementing this every incident is reported.
Yes, thank you for that question. The question was whether our machine learning model can distinguish between forest cover loss in pristine primary forest and in forested farmland, for example. And I have to say that we are currently running the model on all areas of the land surface, but then the Kenya Forest Service GIS team essentially only use the data over their protected forest areas. So we're not using the alerts outside of those areas that are of interest to the Kenya Forest Service in this particular example of the application. What we can see sometimes in the deforestation alerts is that we see trees being cut outside of the protected forest areas, but because they fall outside of the jurisdiction of the Kenya Forest Service in this case, they are not being followed up in the same way, I guess is the answer. But in principle, the change detection mapping can identify tree cover loss of any kind in all areas. It also depends on the type of model you train, because we have trained various different machine learning models over time. And depending on the classes of interest, that's one of the advantages of this software. You can train your model on the classes that you want to monitor.
Yes.
I've got a follow-up question on your answer. So what trainings, how did you collect the training samples for your machine learning method? And also, how did you validate these results you get?
Yes, okay, so how did we train the machine learning models and how did we validate the classifications? That's very good that you're asking this, because I didn't go into detail about this at all. So we trained the model by looking at pairs of Sentinel-2 images over areas where we also had high resolution, and I should say 3 to 5 meter resolution Planet images. Planet has made many of its images available under the so-called NICFI initiative, the Norwegian Climate Fund sponsored initiative. They make monthly mosaics of 3 meter resolution available as part of this. And we have used that for verifying that something really is a forest cover loss. And that's how we trained the model. So using spectral information from Sentinel-2 images and manual selection of training sites on screen. So that's where we define the classes that we want to train. And how did we come up with these accuracy statistics that I was showing? We were using the Planet NICFI data, the mosaic data at 3 meter resolution over those areas that we identified. And we had a stratified random sampling approach to find areas where we had forest cover loss or no forest cover loss. And you looked at the corresponding high resolution, 3 meter resolution images to verify the detections from the 10 meter resolution forest alerts. So that's how we did it. And of course, then in a less quantitative manner, we have the field verifications from the Kenya Forest Service, of course, that also indicate that there seems to be quite a good detection rate of something going on. So when I was fortunate enough to be able to go to Kenya again after the pandemic in September this year, we spoke to some of the rangers in Kwale, and they told us that this software actually had made their lives much easier because they know where to go. And even if they only find something every other time that they go to the field, that's a much better success rate than not knowing where to go.
Excellent. If there are no more questions, we wanted to wrap up a little bit earlier today because I know some of you have got commitments to move on to at 3 o'clock. I don't think we have any questions from our online audience, but if you'd like to join us for tea and coffee afterwards, if you do have any further questions for Heiko, then I'm sure he'll be happy to answer them. Any other questions whilst we're in the room? No? Well, thank you ever so much for taking time out. Apologies for the few hiccups we've had. We will learn from those lessons. And thank you very much to our online audience as well. I'll be in touch with everybody to let you know how you can view the recording once it's available on YouTube. So thank you very much.